Good morning guys, welcome back to my new video. Today we are going to discuss the class 9 CBSE chapter number 8 science motion, the chapter number 8 of science of class 9. So it's CBSE, like it's full NCRT. So let's start. Motion. So what is motion? So here we're going to see. So change in position of an object with respect to reference point is known as motion. So here we can see the position of an object is changed from its respect point to the reference point. It is also known as motion. So if we take an example over here, if we take space as reference point, then we all are in a motion. You know, right, the space. If we take it as a reference point, then we all are in a motion. Here it is written. So the motion of an object is always decided on the basis of the reference point. So here it's saying that the motion of that object is always depends on the basis of the reference from where it started. Okay, so I'm going to show the characteristic of this. So let's head to the next page. So guys, here I've written 3 characteristics of motion. Okay, so motion. First, motion can be defined as the change of position of an object with respect to time, as I told before. Second, motion is mainly described in terms of distance, displacement, speed and time. Remember, distance, displacement, speed and time. It always described on the terms of distance, displacement, speed and time. Third, motion of an object depends on the reference frame of the observer. So it depends on the observer how he sees it. Okay, now let's head to the next page and I'm going to explain scalar quantities and vector quantities. Okay. Now, scalar quantities and vector quantities. Quantities which only have magnitude are known as scalar quantity. So, magnitude, I'm going to show it later. Over here it is written, I will show you guys. Okay, so quantities which only have magnitude are known as scalar quantities. Only magnitude. And quantities which have both magnitude and direction is known as vector quantities. It's over here. I will show the examples now. For example, scalar quantities. So here we can see speed is 20 km per hour. So the speed, the 20 km per hour over here, magnitude, it is also known as the magnitude. We can also say 50 km per hour, 40 km per hour, but here we can see its magnitude is 20 km per hour. Now here we have in vector quantities, we have both speed, magnitude and direction, both. So here we're gonna see the speed is 20 km per hour towards north. So 20 km per hour magnitude, as I told here, and direction, it's towards north. We can also say 20 km per hour towards south. Okay, so let's head to the next page. Now here we have the examples of scalar quantities and vector quantities. So first let me tell you that scalar quantities only have magnitude and vector quantities have both magnitude and direction. Okay, scalar quantities. So the examples of scalar quantities are as follows: time, distance, mass, volume, speed, etc. There are many more. And for vector quantities, force, acceleration, displacement and velocity. So remember these: time, distance, mass, volume, speed are example of scalar quantities, and vector quantities are force, acceleration, displacement, velocity and etc. Now I'm going to show you about distance and displacement. Okay, now here, distance and displacement. Okay, the total part traveled by an object is known as distance traveled by the object. So for example, you go somewhere, so you travel a certain destination, like certain kilometers or something, to reach the final position where you have to go or where you have to reach. So we're gonna say it as distance. So the total part traveled by an object, for example you, so total part traveled by an object is known as distance traveled by that object. Okay, now displacement. Displacement is the shortest path from initial to final position of an object. So I'm going to tell you before, initial means like wherever you start that, wherever you have to go, wherever you start the like distance when you have to cover. So whenever you start from initial, it is known as initial. From there to final position where you have to totally reach at the end. So here is an example. So we can see from A to B and B to C, we can see that from A to B it's 3 meter and from B to C it's 4 meter. So it's a distance. If we go directly A to C, for example, Ram has to go from distance A to C. So he will travel 7 meters. But here, if we talk about displacement, so we can directly say that if Ram travels from A to C direct, it will be a shorter distance and it will be a short path. Okay, so this is what we call as displacement. Let me show you more examples and difference between them. Okay, so here is the difference between distance and displacement. Let me read it out. Distance. For first point, the total path length covered by an object, or the length of actual path traveled by the body from initial position to final position. This is the definition of distance. You can take any one of these. Both are same. So displacement. Shortest distance, as I told, from the final position to initial position. Final position to initial position. The length of the length of the straight line joining the initial and final position of the body. Okay, so these are you can take any one of these points. If you want to note it down, you can just note it down in a notebook or something, whichever you want. Now second point, it is a scalar quantity that it has only magnitude. You can see distance only has magnitude over here. As I told, scalar quantities which have only magnitude. And displacement, it is a vector quantity that it has both magnitude and direction. So as I told before earlier, that in vector quantity there are both magnitude and direction. Okay, so now let's see the third point. It is always positive, and for distance it is always positive, and for displacement it may be positive, negative, or zero. Okay, it can be any of these three from displacement. It depends. Okay, so now let me show you example on distance and displacement. Okay, now here's the example. For example, Ram is over here from A and he has to go to B, and the way is there are two ways in one way. So from one way he has to go like this, from here to here. From A to B he has to fully go round and like that, and then he will reach to point B. But what if I told you can just go in the shortest path? So here you can see there is an option that displacement also. So he can just directly go from displacement way and he can reach a bit more sooner. So here we can see distance is fully it's gonna go like this and this the roads, but in displacement he can just directly reach over there by doing this. Okay, now here's one more example. Okay, assume a right angle triangle with base 8 centimeter and height 6 centimeter. Okay, then the resultant displacement, first let me explain you. Then the resultant displacement will be equal to, okay, here there is 8 square plus 6 square in root. So here if we see 8 square will become 8 8 are 64, and 6 square will become 6 6 are 36. So here we can see 64 plus 36 is equals to 100. Okay, so 100, if we remove the square root of 100, we can get 10. So here we can see as 10 centimeter we can write over here. Okay, so this was the first part of this chapter. I'm gonna end the video over here. I will make the second part very soon. Okay, so thank you so much for watching and giving your precious time. Okay, if you like my discussion, then thank you. Bye.